This is the chapter 4 review. The whole chapter is on matrices. The very first section was an introduction to matrices. And what you need to grab from here is the understanding of how to do the dimensions on a matrix. You go row by column. So this is a 3 by 2 matrix. 3 rows, 2 columns. This would be a 2 by, so 2 rows, 1, 2, 3, 4, 5 columns. So the first number is always your rows. The second number is always your columns. The other thing we talked about in this section was how to solve for a variable using equal matrices. So like on this particular one, the first row, first column equals first row, first column. So 2x equals 40 plus 2y. This gets set equal to that, and this gets set equal to this. Now, the truth of the matter is, you could do graphing, you could do substitution, you could do elimination. Your choice as to which one you would want to do. This one's kind of set up pretty good for substitution, so I'm going to go ahead and let this be my key that I'm going to put back up in the other one. So I have 2x is equal to 40 plus 2 times the y value is 5 minus 4x. I'm going to distribute. So I have 2x is equal to 40 plus 10 minus 8x. I can put the 40 and 10 together. And then I can go ahead and add the 8 to both sides. So I'm going to get 10x is equal to 50. And x would equal 5. And then of course I would plug it back in there. So I have my y value. So I would go y is equal to 5 minus 4 times 5. So y is going to equal negative 15 because it's going to be 5 minus 20. So that's your x and y value for that. All right, the next section had to do with adding and subtracting matrices and scalar multiplication. Remember, the dimensions have to be the same for you to add or subtract them. This is a 3 by 3 and this is a 3 by 3, so they can be added or subtracted. This one has scalar multiplication, so there's a 4 in front of it that I'm going to distribute, and there's a 3 in front of it that I'm going to distribute. So I'm going to do that first, and then I'll add them. So this is going to give me a negative 20, a 20, a 12, a negative 8, a 4, a negative 8, a 16, a 0, and a 24. And this one's going to give me a negative 6, a 9, a 12, a 6, a negative 3, a 0, an 18, a 6, and a negative 3. And then I'll go ahead and add each spot. So first row, first column gets added to the first row, first column. So that's going to give me a negative 26, positive 29, 24, negative 2, positive 1, negative 8. It's going to give me a 34, a 6, and a positive 21. And that would be your resulting matrix. Be careful when you subtract. Okay, you're going to do the same thing you just did up there, but I suggest adding the opposite of everything that's in the second matrix when you go to do it. So you take it and change it to an addition problem. All right. The next section was on multiplying matrices, and so you have to remember that the number of columns from the first matrix has to equal the number of rows from the second matrix. So could you do these? I look, those two match, so yes, I can do it, and the result would be a 2 by 5 matrix. This one don't match, so this one can't be done. This one, they match, so the resulting matrix would be a 2 by 4, the first and the last. Now, you also need to memorize the pattern and be able to multiply two matrices. So, let's work on it on this one. Remember, you're multiplying row, column, row, column, row, column. This one is a 3 by 2. This one is a 2 by 3. So the resulting matrix is going to be a 3 by 3. Sometimes it helps to go ahead and put the locations in there so that you're sure that you've got it organized correctly. So I'm going to go -5 times 6, which is a -30. And -2 times, or +2 times -2, which is going to be a -4. Then I'm going to do second column. Same row, second column. -5 times -3 is 15. And then 2 times 4 is 8. Same row, third column. -5 times 1 is -5. 2 times 3 is 6. Then I'm going to jump down to the next row. 1 times 6 is 6. Plus 3 times -2 is -6. Then I'm going to go the same row, second column. 1 times -3 is -3. Plus 3 times 4, which is 12. Same row, third column. 1 times 1 is 1. 3 times 3 is 9. Then I pop down to the third column, or third row, and go to the first column. -2 times 6 is -12. 5 times -2 is -10. -2 times -3 is +6. 5 times 4 is 20. -2 times 1 is -2. 5 times 3 is 15. So, and then I'm going to go and add these. So that's going to give me a -34. It's going to give me a +23. +1. 0, 9, 10, -22, 26, and +13. So you just got to make sure that you can do those. Section 4.4 had to do with matrices and determinations. Remember, determinations is a singular number, not necessarily a single digit number, but a singular number that represents a matrix. I'm going to remind you how to do it for a second order, which means it's a 2 by 2. Remember, to find a determinant, you have to have a square matrix. If you don't have a square matrix, same number of rows as you do columns, you cannot find a determinant. So I'm going to multiply up, and then I'm going to subtract. So this is going to give me a 19 as the determinant of that matrix. Third order determinants also must be squared. And there's two methods that we did. There's expansion of minors and there's diagonals. You need to know how to do both. For expansion of minors, you grab the first number and then you do the determinant. Remember, determinant is a singular line. This I would have done as a singular line to show you that you were going to get the determinant, but my computer would not do a single line. So I have a 3, and then I'm going to mark out the row and the column that it's in, and I'll put the rest of them in here. So I'm going to have to find the determinant of that. Then it's minus the second number, -5, times its determinant of the expansion of its minor. So I mark out this row, this column. So 2, 3, -1, and 10. And then it's plus the third number, and the determinant of the expansion of its minors. So I mark out this row and this column. So I'm going to multiply up, and subtract, multiply up, subtract, multiply up, and subtract. So it's going to be 3 times 17. And this is, I'm going to add the opposite here, so it's going to be plus 5 times 23 plus 4 times 11. So this is going to give me a 51 plus 115 plus 44. So when I do that, I'm going to get 51 plus 115 plus 44 is going to give me 210. If I did all my math right. We'll find out in a minute when we do diagonals. All right, we're going to do the same matrices, but this time we're going to do it by diagonals. So I need to recopy the first 2 columns. And then I'm going to multiply up. So I'm going to get a 30. I'm going to get a positive 15. I'm going to get a positive 56. And I'm going to add those. So 45 plus 56 is going to give me 101 up here. And then I'm going to multiply down. So I have 12. I have negative 21. And I would have a negative, let's see, it's going to be a negative 100. So I have 12 minus 21 minus 100 is going to give me negative 109. So then I subtract 101 minus a negative 109, and that's going to give me the same answer of the 210. Okay, so you got to be able to do that both ways. Remember to find the area of a matrix using determinants. It's going to be 1/2 the determinant, and you're going to place the x, then the y, then the x, then the y, then the x, then the y, and then you're going to fill in here with ones. Now, obviously, I'll have to find the determinant of that, so I'm going to do it by diagonals. I'm going to go ahead and recopy my first 2 columns. So I'm going to multiply up, get 16, multiply up, get 30, multiply up, get positive 4. So on the top I've got 40, let's see, that would be 46 plus 4 more, that's going to be a 50 on the top. Multiply down, 24, multiply down, negative 8, multiply down, negative 10. So I'm going to have 24 minus 8 minus 10, which is going to give me a 6 on the bottom. I'm going to subtract. So I'm going to get a 44 right here, but remember I'm taking half of it. So this is 22 units squared, and that would be the area of the triangle with those as the vertices. All right, section 4.5 had to do with the identity and inverse matrix. Very similar concept to like 5 times 1 is equal to 5. This is like what number can you multiply by 5 and have it not change its identity. Remember the identity matrix, it's 1, 0, 0, 1. If I multiply that matrix times that, it's going to give me the same answer. The other, which is an inverse, obviously there's a matrix that when you multiply by 5, the answer is going to be your identity matrix. So that's what we worked on, trying to find that. If you remember, there was a pattern, and I'll go ahead and show you the pattern here. It was 1 over the determinant of that matrix And then you multiply that, you switch these two, which obviously in this case it's not going to affect it, and then you take the opposite sign of those two. So you get that. So I'm going to find this part first. So I'm going to go 4 times 4, which is 16. And I'm going to go 2 times 5, which is negative 10. I'm going to subtract, so I've got 1 over 26 that I'm going to multiply by my 4, negative 2, 5, and 4. So the inverse matrix, which is denoted as that's the inverse, if you will, or it could be done like that if you want to call the matrix A. So if I called this matrix A, this is the inverse of matrix A. And the inverse of matrix A would be 1 over 26 times 4, which is going to give me 2 over 13, reduced down, 5 over 26, negative 1 over 13, and 2 over 13. And that's going to be the inverse matrix. So if I multiply this times this, it would give me that. Identity matrices, remember, are always diagonals of 1. So if you have a 3 by 3 and want to know the identity matrix, you do the diagonals of 1 and fill in zeros everywhere else. All right, again, let's do another one of these with a pattern. We could call it a to the negative first power if we're going to call this matrix A. So I have 1 over the determinant of negative 5, 1, negative 2, and 3 times my pattern. Remember, these two switch places. And I take the opposite signs of these two. Notice how this is the determinant and that's the matrix notation. Okay, so I have a negative 15. I'll actually do it down over underneath here. And negative 2. I'm going to subtract, so I'm actually going to add. So I've got 1 over negative 13. So I've got that. And then I'm multiplying by 3, negative 1, 2, and negative 5. So the inverse matrix would be negative 3 over 13, negative 2 over 13, positive 1 over 13, and positive 5 over 13, because I'm multiplying. Okay, doing scalar multiplication right there. Here's a couple more to practice with. If you want to, you can pause the video and come back to it. So I have 1 over 2, negative 3, 0, and 5. I'll have to pause this video real quick. All right, continuing on here. We got to find the determinant of this. So it's going to be 10 and 0. So it's going to be my 1/10. And I'm going to multiply it by, these two are going to switch places. I'm going to take the opposite sign of those two. And of course, you can't take the opposite sign of a 0. So I've got 1/10 times this matrix. So 5, 3, 0, and 2. Which is going to give me a matrix, I'll do it right here, of 1/2, 0, 3/10, and 1/5 when I multiply those. All right, this one, I'll do it out here, have 1 over, and again, remember we're finding the inverses here. That's what we're working on. Okay, so 1 over 5, negative 6, 7, and 3, multiplied by, these two switch places, and those change signs. So I've got 15 minus negative 42, so that's going to give me 1 over 57 times 3, 6, negative 7, and 5. Some of these are going to reduce. The 3 over 57 reduces to 1 over 19. 6 over 57 reduces to 2 over 19. And negative 7 over 57 will not reduce. And 5 over 57 will not reduce. Okay. Alright. Then you're going to use matrices to solve equations. First thing you're going to do is you're going to put these in matrix form. So I'm going to have a 4, a 6, a negative 2, and a 4. So those are the coefficients. Times x and y equals 22 and negative 2. So I'm going to do the inverse. So basically x and y is going to give me the inverse of this times that. So it might be worth it to you at this point to put it in your calculator. So when I do that, so I'm going to call this matrix A. I'll call this matrix B. And then what I'm going to do is I'm going to multiply the inverse of matrix A times matrix B. Remember, to get the inverse, you select the matrix. And let's see. Somehow I got the same matrix in there. Okay. So I select matrix A. I hit x to the negative first power. And then I'm going to times it, times matrix B, and I'm going to get a value for x and y that's equal to 3, negative 5. So x is equal to 3 and y is equal to negative 5. Just remember how to put those into your calculator. Same thing with this one, and these you have to use your calculator on because we didn't learn how to find the inverse of a third order matrix. So I would make this matrix 5, 4, 6, 1, 2, 3, negative 7, 9, and 8 times x, y, z equals 46 and 72. Again, make that matrix A. This one matrix B, and then to solve for it, you're going to do the inverse of matrix A times matrix B. So give me a chance, I'll put those in my calculator. And then I will make matrix B, this part, which is a 3 by 1. And then I'm going to select matrix A, then I'm going to do x to the negative first power, and then I'm going to select matrix B, and it's going to give me, and these I'll have to round, 9.3, 39.9, and negative 27.7. And that would be your x, y, and z. All right, your homework for the review is page 246 through 247, 12 through 42 even.